Okay, hi everyone. So, um, okay, so I reviewed the previous video, and I'm very sorry if my background there are background noises. Unfortunately, I really can't control the noise outside of my office because I'm currently in my office, as you may have noticed. So, sige, we will continue our discussion from the last time. So, I've cut the video to 30 minutes because I think that it could get a little, the size could be kanang dako ba, and I would have a hard time uploading it on YouTube. So yeah, so now let's continue. So we have here our um sa tawag ani? Sa ganini? Our pseudo code now on summing all the elements on the list. Now let's analyze this. If is this an okay, or how do we know that this algorithm is okay? It's fine, like, it solves the problem, yes, but how fast is it gonna be if we run it on a computer? And okay, so you won't be able to really appreciate this one. So disclaimer na lang ko first, because our algorithm is, as you may have noticed, very simple lang, no? But it is enough for you to understand how to analyze this algorithm. So first is that we have here profiling. So profiling is it will not go into this deeper because this requires you that kanang padagan na gid mo, and then you will actually look at how much time it took for the computer to run the your code. So, technically, for those who have naka-program na, you would see kung pila ka milliseconds it took for the execution of your code. So, that's what profiling is. You will record it as to how many or sa gid siya kapaspas in your actual device, no? Now, this is not really very effective because devices can vary. So, there are devices na medyo paspas from the rest. There are also devices na hinay. There are also devices na um, dili kay kaparan og ani ka simple, but kung complicated na paspas kayo, and so on and so forth. So, profiling can be done if you are gonna be creating an algorithm exclusive for that certain device. No? So, say for example, you're gonna be programming a robot. So, katuragin yung robot ang gamit na in mga code. So, of course, you will fine-tune your algorithm to the specs of the robot so that paspas good siya when it comes to sa katong kung iparani mo to siya nga code ana nga robot. Okay? But if not, like if you're gonna be creating an algorithm that is general for all, that can be implemented or executed on across different devices, then profiling is not a technique in identifying um, how efficient your code is. Another is the counting operation. Counting operations is theoretical in a sense na same sila sa asymptotic actually, in a sense na it just approximates how fast your algorithm is. So it's technically just in theory, but it is the closest, no? It is the closest approximation on how fast your algorithm could be. So this tool is what usually is being used in analyzing your algorithm. Okay? But it is more on this one, the asymptotic notation. But first, let's tackle the counting operations. What does it does? What does this do? Okay, so when you count operation, it is like counting each and every process involved in your algorithm, and you count it as one. Like for example, this one. So the process of adding all the coins in your pocket. So when you say counting, this one, like, so tawag ni, you say counting operations, you need to count how many steps it took you to get to the solution. So first step is that, of course, you have a brain. So that's one step. First step. So that could count as one. I will change the color of this one. So this count as one there. And then getting the coin could be one process. Inputting it to your brain is would be another process. So in total you have three processes here so far. And then getting another coin is another process. Putting it back, putting it on your brain is another process there. And then adding is another process. It's like that. No? Specifically counting all the processes involved in your algorithm and counting them and giving them at a 1 point, no? A 1 point for each of those counting that you did, and then at the end you will add them, and then that's gonna be how much operations your algorithm will be performing, and it could be an approximate on how fast it will perform, right? Because the more operations your algorithm would have, of course the slower it will become. So in this algorithm that we created last time, we will count 1 point per each operation here. So initialize as a list, we can just give that a 1 point. Now since we already assume that the list has an element in it, so um, all the process involved under this assumption will not be counted. No? So this na to na siya ihapon because again, this needs specific steps and we cannot count that one if wala tayo specific na step. And since we just assumed it, so di lang sa nato na siya i-add. Okay. Next is this one here. We will not be counting again. Kanina naka-backslash ha. Next is this one. Of course, let sum is equals to 0. So that would be 1. And then let S be the size of L. So that could be 1. Okay. Now, this one here is a little bit tricky because technically this statement will repeat. No, since this is the scanning process, will repeat until S, right? So we will start at 1 until S. But note na this also involves a step. So say for example here, ako ginibalik-balik na inyong brain na walay solution. Okay. So say for example this one, no? That one. So technically when you scan, first magsugod mo sa 20, kaya pinakauna ninyong makuha, and then you put that on your brain, and then next, di ba? That is a repetitive process, and each of that process is a step, of course. Hatagan dito ninyo yung points isa-isa. However, when you reach the end, no, if you will have this a little analyzation sa inyong brain, kung mupunit pa ba mo sa inyong bulsa, mukuot pa ba mo sa inyong bulsa. And then, if wala na, then it means mana, di ba? Mana, di na mo mag-add, right? So, once mo reach mo at the end, there's always this question as to mupadayon pa ba ko or not. Na if naa pa ba or not. That's always the next question in your mind if you're gonna be scanning an element or if you're gonna do a repetitive task. You would ask each kada human ninyo og scan, kada human ninyo og butang sa inyong brain, you would ask, na pa ba ni sulod? Okay na. Paano? Pa pa 20? Okay na pa ba ni sulod? Okay na. Pa pa 5? Na pa ba ni sulod akong bulsa? Okay na. Pa pa piso and on. So, pag mo nana mo sa last na coin at the end, bukod paghihapon mo sa inyong bulsa just to check. Okay, wala na gid siya. So, piso na gid to last na coin. So, it's the same here. So here for I equals to 1 to s, there's always a test at the end to check if napaba ko sa bound sa s or nisubran ako sa s. Diba? So technically, this process here will occur s times plus 1. Okay? So, kung tag 1 point, say for example, s is 5, sugod ka sa 1, so process siya sa 1. Process siya sa 2, so that's 1, 2 nga process na. Process na po siya sa ika-third, so 3. And then 4, another process there. So this is your process points. So sa process 1, nakay 1 point. Sa process 2, 1 point. Process 3, and then sa 5, so na nakay 5 ka processes. Plus sa katong isa, kakapin sa last, nang check. Diba? So muna siyang S plus 1. So this here will repeat S plus 1 times. However, ang kaning sa sulod, since this will just occur if this is true, right? Kung naapa siya sa S, usa pa man kumuad, pareha gud atong kaganina, right? Kung wala na kay makuha, di na ka mag-add. Diba? So this will just be occurring S times. Okay? So this will be, the process will be 1 times kana, and then 1 times s. Or it could be just s plus 1 para for specificity. Okay. And of course, sa display sum, kas araman mo ma-display sum, so that is 1 point. So now we will add all the processes that we have. So that one, so we will name that as T of n. So what is T of n? That is your runtime in terms of your n elements or your n input. So in this case, this is the number of elements on your list, right? So since n is our element here, yes. So sige, I have a problem kaya wala akong coincide ang variable names. So, ako na lang siyang i-resume. And then I will just name this to avoid confusion as S. Since S is the size of our list. Hindi na siya masunod. Okay. S. Okay. So this is T of S. S is the input or the list size. And then this is our runtime for this algorithm. First we have 1 plus 1 plus 1 plus S plus 1 plus S plus 1. So if we solve that, we have 3 plus S plus 1 plus S plus 1. So that is pila ka book 1 to 5. So this would be S plus S plus 5, or it could be 2S plus 5, right? So 1, 2, 3, 4, 5, and then we have 2S. So the T of S for this algorithm that we created is this one, 2S plus 5. So this is technically the counting operation that we did. That one. So counting operation is just finding your T of S, or in common terms, T of n. Pareha ni variables ra akong gilahi. So technically, your runtime of your algorithm in terms of the number of input. Okay? So, ano to siya? So now we have here our T of S. Now, let's proceed to, kabalo na mo count the operations, we will go to the asymptotic notations. Okay. Asymptotic notations. Asymptotic notations are mathematical ways of proving how fast or how slow your algorithm will be. Like, it's how you estimate the upper bound, lower bound, and the tight bound of your algorithm. Okay, ma'am, what's na yung upper bound, lower bound, and the tight bound of your algorithm? Okay, first let's look into this one. This is your T of S, right? Now, if I will graph this one, that one, no? So, say for example, my T of S is 2s plus 5. So, I will put there y is equals to 2s plus 5. 2x na lang pala. I just changed the variables. 2x plus 5. So, this is the graphical representation of your algorithm. This is how it behaves as your n increases. Note that 2x, the x here is your n, right? So it's like your s there. Now, or your number of input n, okay? And then y is just the rate, no? Now, if you have, say for example, 50 inputs here in your x-axis, if you look at this, the line here, kaning line, makabalo mo nga, okay, increasing good siya, pataas gud ang iyahang direction. It means na as your input gets bigger, your T of n, here, this is your T of n, meaning the time that will take na ma-execute niya siya would increase as well, right? So, if y is your time of execution, n is your number of input, means that as your input gets bigger, your time for execution gets bigger as well. So this is how you look into that. Muna siya ang graph ato ang runtime in finding the sum of your list. Okay. Now, what I said earlier is sa tong upper bound at sa tong lower bound. So the upper bound technically is just ako ano siyang i-copy ha. So the upper bound is, so that is your graph for, this is your graph for your E of n is equals to 2n plus, pila to? 2n plus 5, right? Ako lang i-change ang pan ha, variable 2n plus, okay, where n is equals to s. Okay. So, muna siya ang graph. Now, when you say upper bound is like this line or another function wherein it is always above your actual T of n. So, if this is your T of n, your O of T of n, big O of T of n, there is your upper bound. So, technically, pasabot ana is when no matter what happens, this upper bound, kani imuhang function will not cross your upper bound. There's no way nga mo cross siya sa imuhang upper bound. So, technically, this could be the highest estimate of your T of n. So, this could mean na with this one, you can say na muna iyahang worst case or muna iyahang function or kaning na graph here, muna ang kaning, how will I say this? It will never cross T of n. T of n will never cross this one. So this could be a bound stating na no matter what the input, mo din siya ang kural ani ni T of n. And it will never be greater than that. So that's your upper bound. So nganong naman na yung anak mo naman tayo upper bound, tayo lower bound, and all. Tayo upper bound. So the upper bound just gives scientists a, or katong mga mo analyze to algorithm, an estimate as to mo day na ang iyang pinakataas na bound na di siya mo cross. So we can surely say na below ani is mura tong mura tong mga area ang pwede masudlan ni TFN. Okay. Okay, I'm charge up. Kadali. Now, because we have upper bound, we also have a lower bound. So, ang lower bound. So, saan ang lower bound? Lower bound is, as it names suggests, nasa sa ubos. So, that's your lower bound. So, your lower bound is somewhere below your TFN, and this is the lowest na pwede makaadto ang imuhang TFN. But it will never cross it. It will never cross this line. So, this is your lower bound. Lower bound is the big omega. That's your lower bound. Ako lang i-confirm. Maglibog ko sa omega o sa theta. So, this is your big omega here. This is your big O, this is your big omega, and then what is theta? Theta is your tight bound. So, it's like a combination of your big O and your big theta. Your big omega, your big theta is the line, the function that technically encloses your T of n here. So this is your theta. Okay? So, ano siya? That's how you analyze algorithm.